Good morning also from my side. Today I'm going to present a work that we did together with colleagues or a group of computer vision of the Free University of Bolzano, Bozen, and my research unit in the field of industrial plants and systems. So we are not civil engineers, but we are industrial mechanical engineers and computer scientists. And today I'm presenting, let's say, this interfaculty collaboration that we did last year, also involving a local company in the field of mechanical, electrical, and plumbing. Great. So mechanical, electrical, plumbing are complex activities, also because in Central Europe, of course, real estate prices are increasing. So this means that flats, apartments are decreasing, are becoming smaller. And so, of course, map systems need to fit in smaller apartments, smaller places. This is often complex in construction projects because errors are detected in a late stage, usually. So usually when you are on site, errors are detected, for example, clashes. And in this case, it's too late because, of course, detecting an error on site creates problems because trades and companies start to improvise and try to solve the error, and this creates then maybe next errors or following errors. And traditionally, project monitoring is often done paper-based or based on 2D drawings with limited digitalization support. So this is often the case in conventional construction projects that we see also in our region, in Italy, but not only in our region, so in, let me say, in Central Europe. And the reactive decision-making is often because of limited project visibility. And therefore, we believe that mixed reality, augmented reality can give a good contribution in this field because it can show you immediately if there are problems, and so you can see problems in advance and so have the time to implement improvement actions. Right. The approach, what we developed, consists basically of 3 modules. So module 1 is, let me say, the planning module. In this case, you define the level of detail of the BIM model, let's say, the detail of the components that need to be visualized in the augmented reality headset. But in this case, you define also the level of detail of monitoring with the planning module. Then module 2 is the scheduling module, so this is the core of the application. And with the scheduling module, we implement the so-called rolling scheduling or rolling wave scheduling approach. This is an approach that is it's known in the automotive industry, so in manufacturing, where you do not a complete schedule at the beginning, and you do small schedules and updates, schedule updates. And in this case, you're able to manage variations or also delays. And of course, in this case, the rolling scheduling approach requires that you monitor also frequently. And in this case, scheduling is not done at the beginning for whole project, but scheduling is done frequently. Let's say every week you schedule and you monitor, then based on the monitoring you schedule again, then you monitor, based on the monitoring you schedule again. And in this way, this is also a little bit the idea of the last planner system, if I can say, let me say, an old lean methodology, quite old. But in this case, you're able to handle variations and to see if there are variations quickly on a construction site. And so you avoid that the variations are propagated down throughout the different trades throughout project execution. Great. So the application was developed for the Microsoft HoloLens 2 head-mounted display. So we used the SLAM algorithm in the head-mounted display with HoloLens. And of course, we used also the voxelization approach. So we used voxels. Voxels, you know, are 3D pixels, let's say. And we had the level of detail of 5 centimeter voxels. So this was the grid that we used to represent and also to monitor then afterwards the installed mechanical, electrical, and piping systems. And to monitor, we used an indicator which is called the intersection over union, IOU indicator, and this calculates the intersection between the representation of the augmented reality. So let's say the building information model, the BIM model, and then the installed pipe of the mechanical, electrical, and plumbing system. So in this case, the system knows what needs to be done according to the schedule, so what is represented, what is shown in the head-mounted display, and then it compares what has been completed according to the SLAM algorithm and according to the point of view of the user that is using the head-mounted display. Right, so we tested our prototype. The mainly test scenario was the construction of a big binary storage facility in our region. So you see it on the top of the figure here. And you see here how the ventilation pipes are visualized in the head-mounted display. We had problems with lighting. So of course in cellar areas or in this binary storing facility, lighting was not very well. So we had to install additional artificial lighting for using the head-mounted display or the application. And unfortunately, we were not able to test the monitoring module on the construction site directly because we had a problem with synchronizing ourselves with the company. The company already completed the piping and they covered then the piping, and so we were not able to test the monitoring module, but we tested the monitoring module in our laboratory, in the extended reality laboratory, what I'm going to show afterwards. And you see here, so we tested the monitoring module with 5 different component groups. So component group A, the fan coil unit, then component group B, fan pipe supply, then C, the wall channels here, electrical pipes, D on the other hand, and then the air exchange pipe, E, the big one at the end. And according to the indicator intersection over union, you see that, for example, air exchange pipes, E, and fan components, B, so these two were identified with a higher level of accuracy, let's say, with a higher IOU indicator, and other components, for example, the fan coil unit or the wall channel and electrical pipes, these have a lower level of, or a lower value of the IOU indicator, intersection over union. And this shows us, of course, the sensibility of the indicator of the approach for included components that are not completely free, let's say. For example, here the channel, electrical channel that is installed on the wall is not completely free, and of course in this case it's not so easy to recognize the position. And this of course indicates that we need further indicators to incorporate in our monitoring or our scheduling monitoring module. Advantages of the approach is that it requires no labeling of the training data. So in this case, labeling is done, let me say, by the BIM model, by augmented reality, but by using the SLAM algorithm or SLAM approach and the IOU indicator, you do not need to label a data set. This is an advantage. And then, of course, also according to the flexible level of detail modeling, according to module 1, you are able to define the level of detail. This may also improve the IOU indicator if you level more in detail the different components that you're going to monitor afterwards. Yes, and of course, sensitivity to lighting is this, in this case, also partly responsible the head-mounted display that maybe has problems in this kind of scenario. And the approach has a little bit limitations in the field of partially occluded components, and therefore we were thinking in future to implement an additional feature of the head mount or of the application, and this feature indicates the user where he has to look in order that the pipes are shown or are visualized in the head mounted display, and this helps then the monitoring of the progress. Right, so this brings me to the end of my presentation. The case study shows potential in this field, potential in order to use augmented reality not only for visualization but also for monitoring. This is very important if you do or if you have an assistant system for construction management like this one that I presented. And future works, of course, will include including viewpoint changes in the application and doing an extensive validation on active construction sites in future projects with other similar companies in this field. So thank you very much for your attention, and if you have questions,